Okay, able to see my screen, right? Or yes, screen is visible. Okay, cool. Yeah. Okay, so towards the end of last class, we saw the sum of n terms of a geometric progression. So if I have a geometric progression with ratio common r, ratio r, a, ar square, all the way till the nth term would be a r power n minus 1. Right? The number of multiplicative hops is one less than the term itself we are trying to reach. That's how we get the last term as ar power n minus 1. So this last term is typically denoted by either tn or un or even an, sometimes a suffix n. Be careful, sometimes the suffix should not be confused with the multiplication. Similarly, the first term, sometimes people call it t1 or u1 or even a1. Okay, they're all synonymous. And then we saw that the sum of n terms we derived is a into 1 minus r power n upon 1 minus r. And you could also write it as a times r power n minus 1 upon r minus 1. Okay, so both are, let me just check if my recording is going on. Okay, yeah, recording is on. Okay, so let's just verify a simple example. Let's take the same example that we started yesterday. So I'll have my 2, 6, 8, sorry, not 8, 18, 54, 162. So let's try whether the sum works for these 5 terms. First, let's numerically just add it literally by adding 2 plus 6 is 8, 8 plus 18, 26, 54 plus 26 is 80, and then 80 plus 162 is 242. So this sum is 242. Okay, now let's verify. So A is 3, A is 2, R is 3, and the number of terms is 5. And I'll use this formula because R is bigger than 1. I want a formula where it's a positive number, right? So it's 2 times 3 power 5 minus 1 upon 3 minus 1. Right? That becomes the sum of 5 terms. So 3 minus 1 is 2, cancels off with the 2 here. 3 power 5, we all know. 3, 9, 27, 81. 81 times 3 is 243. 243 minus 1 is indeed 242. So it matches. Okay. And let's take another example. Let's take a decreasing series now. So let's do 8, 4, 2, 1, half. Right? Okay, one more. Let's say 1/4. Okay, 6 terms here. So again, same thing. A is 8. My common ratio is always the latter upon the former, right? Just like in common difference, it was the latter minus the former. So it is half here. Okay, and I'm looking to add 6 terms. So what is the sum? 8, 4, 12, 14, 15, 15.75. So the expected sum is 15.75. 15 3/4. 15 3/4. Or if you want to write it like this, it's 63 upon 4. Let's see what we get. So A times, now I'll use the 1 minus r power n because r is less than 1, right? Just to avoid negative numbers both in the numerator and denominator, I'll use half power 6, 1 minus half, right? 2 power 6, we all know, is 64. So 8 times 1 minus 1 by 64 is 63 upon 64 in the numerator. 1 minus half is half in the denominator. The half goes up to become a 2. So it's 16, and that 16 knocks off with the 64 to give a 4. So indeed, we get the 63 upon 4. Guys, you're with me completely? In both examples, the sum works out as expected. Okay, now, all good, right? Sarah, you're with me as well? Dave? Okay, cool. Now, the only additional interesting bit that happens with geometric progression, which is not true for an arithmetic progression, is this concept of sum till infinite terms. It's denoted as S infinity, right? The number of terms is infinite, right? What happens when we add up those infinite terms? Hi, Amit. Welcome. We just recapped the sum of the terms in a geometric progression, and we did a couple of examples to validate that. That's all we did so far. right? Amit, you're able to hear me, right?
Yeah, I can.
Okay. And now for geometric progression, it's unique to geometric progression that we can talk about sum till infinite terms. And we can only do that if the common ratio is less than 1, right? For example, actually, what I'm saying is not exactly right, but I'll just come with a small correction right after this. For now, just hold on with me. So it's R is less than 1. For example, you can see here 8 plus 4, 12, 12 plus 2 is 14, 14 plus 1 is 15. You're seeing it's almost approaching some number, right? It's not bloating up, right? 15.5, 15.75. And then if you add one more, it'll still be even less than that and even less than that. So the sum is not bloating away, but it's converging to some value. In fact, you can easily guess that value is close to 16. If you just do a couple more terms, you're seeing that it's always approaching 16, but not exceeding 16. But we can actually prove that it'll actually converge to 16, or the sum infinity that we call S infinity will be 16. If at all you go for adding infinite terms, it'll be 16. If you don't go for infinite terms, if you go for a million terms, in reality, you don't approach infinity, it'll approach 16. That's the only difference, right? Now, how do we arrive at this, the value into which it is going to converge? So if you look at the formula here, what is it? A into, you'll use the 1 minus R power n, since R is less than 1, by 1 minus R, right? So again, let's take the same example, 8 into 1 minus half power, I won't say 6 now, I'll say n, right? By 1 minus half. Now just imagine n is not 6, but let's say n is even 100, forget even 1,000 or a million or a zillion, right? 2 power 100 is such a tiny number, right? In fact, can estimate later when we do logarithms in more detail, we'll know this is approximately 10 power 30, right? And then you can imagine 1 upon power 100 will be such a small fraction, 0 followed by like roughly 30 zeros, right? It's very, very tiny. So this half power n, right, as n approaches infinity, so what I'm writing is technically, okay, so I'll just for namesake, I'm writing like this. So don't write like this. If I put half power infinity, right, then this term is going to vanish, namely half power million or half power 1,000, whatever it is, it's going to be practically 0. Let's say it has 0, a decimal followed by hundreds of zeros. So practically it's negligible compared to the 1 which is here. So 1 minus that is literally 1. So it will become 8 times 1 by 1 minus half, which is 8 upon half, which is 16. Which is why we are saying it's converging to 16. Or more generally, as n approaches infinity, so in mathematics, we use the word approaches is denoted by this arrow, right? As if it's heading towards. So as n approaches infinity, the S infinity is A by 1 minus R. The R power n vanishes, essentially. The long story short, R power n becomes so negligible that the numerator is practically A into 1. Okay. So far, so good. Amit, you with me completely on this? Yeah. Okay, cool. Now, the only small correction I said is R need not be less than 1. And in fact, in a way, this is wrong, because one could say, what if R is negative? If I'm looking at the geometric sequence 3 minus 6 plus 12 minus 24 plus 48 minus 96, R is indeed less than 1. R is minus 2 here. The latter upon former is minus 2. The ratio is minus 2. But what's happening? Let's try and add a few terms. 3 minus 6 is minus 3. Minus 3 plus 12 is 9. 9 minus 24 is minus 15. Plus 33. Minus 63. So it's going up and down, and it's swinging like big numbers like this, right? So it's swinging quite a bit like this. That's not converging. In fact, it's going anything but converging. Converging, at least if it's going heading in one particular direction, it makes sense. Directionally also, with every alternating term, it's swinging from a huge positive to a huge negative, right? So it's not enough to say R is less than 1. R should be less than 1 in magnitude. So R can be negative, no problem. But it should be less than 1 in magnitude. R can be minus 3/4, for example, right? So I can talk about what is the in fact, can you guys work out? Suppose I have the geometric sequence 16 minus 12, 9, right? Minus 27 by 4. Can you guys work out S infinity for this, please?
4.7.
4.7.
64 divided by 7. Approximately 9 point something.
Okay. All right. Let's give
9.142.
Okay, Moksh, thanks. But let's give everyone some time, and I'll call out like who should call out the answer, please. Let's take turns. Okay, anyway, since Moksh has called out 64 by 7, he says, let's see where you guys get the same thing or a different answer. You don't need a calculator for this, guys. You can just use hand. Dave, if you're using a calculator, you can just put it down. I'll let you know, because for some papers, there's no calculator allowed, right? So for small computations, don't get addicted to calculator. Okay, so A by 1 minus R, the starting term was 16, and the common ratio is minus 3/4. Right? So indeed, it's what he said, 16 into, this becomes 7 by 4, right? In the numerator, in the denominator. Therefore, it is indeed 64 by 7. Yes. Well done, Moksh. So approximately how much is this? 9 point something, right? And you can see, you can always verify when you get an answer, you can literally add the first few terms and see it for yourself. 16 minus 12 is 9. Sorry, 16 minus 12 is 4. 4 plus 9 is 13. 13 minus roughly how much is this? 6, right? So if you add, you need to go a few more terms. It is not so direct here because the common ratio is substantially big. It's 3/4, right? Or negative 3/4. So which means it's slowly decaying as opposed to a fast decay like this, right? So you'll need a lot more number of terms to see it actually converge, right? But indeed, this answer is right. So Sarah, did you get the same answer? 64 by 7?
Yeah.
Okay, cool. Okay, let's do some problems. Let's do. Okay. Okay, can we do this one? Okay, we can start discussing like they're all fairly easy questions, right? Amit, you want to help with the first one? Find an expression for UN before
10
it's nth.
times 5/6 to the power of n minus 1.
Sorry, please repeat again.
10 times 5/6 to the power of n minus 1.
N minus 1. Okay. Okay. Just because the word before is highlighted, always verify with like one simple example. Suppose n equal to 1, then your answer is saying 10 times 5/6 power 0, which is 10. So is it true that before the first rebound, the maximum height is 10? Yes, it is, right? Because it's just starting. And then it's going like this, right? Like this, like this. Okay. So for n equal to 1, it's correct. And therefore, it must be right. 10 times 5/6 power n minus 1. Okay. What shall I say? Before it's nth. Yeah, correct. How high will the ball bounce after the 5th rebound? Yeah. Let's see. Thais, you want to get this?
So I just replaced the.
You can just give it in terms of 5/6 power. You don't need to give the numerical value.
Sorry, I didn't.
You can just give it as a power of 5/6. You can just say similar to what
So it's.
Yeah,
So it's 5/6 power 6.
5/6 power 5, no? Because Effectively,
yeah, okay.
this is equivalent to saying before the sixth rebound, right?
Yeah.
After the
Okay,
fifth
yeah.
rebound is same as okay. And then we already found and agreed that the most general expression is this for before the nth rebound. So you just have to put n equal to 6 in the first equation, right? We just apply
Okay,
n equal to 6. Yeah. So 10,
Okay.
10 times 5 by 6 power 5. Sorry, someone else had a comment. Moksha, did you have a comment on this one or someone else? I heard some other voice. Dave, was that you?
Not me, sir.
Okay, cool. Okay, so Dave, you want to get the last one? How many times has the ball bounced?
So can I equate it? 10 into 5, 5 by 6 is 10 minus 1 is equal to 6 to 5, 0 over 1 to 9, 6.
Yeah, correct. So, and then do that and tell me the answer,
Yeah.
please. Yeah, Dave should not
I think
be
n
too.
should be 5.
Okay. Okay, so what is your final answer for part C then? I'm just saying, I'm just asking you because you might compute n, but the final answer may be 5, maybe 6, maybe 4. You have to be very careful when this after and before and all is there, right? For all you know, it might be 5 as well. All I'm asking is, what is the answer to this question? Your n might be 5, your m might be 62. I don't care.
5 times.
Okay, Moksh, do you agree or disagree?
So I think I would disagree.
What would you think?
I think it's 4 times.
It's 4 times. Yes. So Dave, so n is indeed 5, but what is n? N is saying before the fifth rebound, it has reached a maximum of this much, right? The definition of n is just go with the first one, right? Un is the ball's maximum height before its nth rebound. So if you apply the formula before the fifth rebound, it's reached this much height. That means what?
Oh.
It has only bounced 4 times so far. Okay. So again, not just Dave, for everyone needs to be careful. You might compute some intermediate value, but that need not be your final answer. What you call out is very important, right? Okay, cool. Even here, when Amit called out, it's very easy to just say AR power n minus 1. And the first tendency is to put that AR power n minus 1 without thinking too much. In this case, it turned out to be fine, but you can always frame a question where if you blindly apply a formula, you'll get a wrong answer. So be very careful. Moksha, well done on that. Okay, now part D is something I'm going to include. What is, okay, what is the total vertical distance the ball will cover after bouncing thousands of times? Okay, I'm not writing, it's too much to write. You guys heard me, right? So what is the total vertical distance? So just, for example, in the picture I've illustrated, it's also traveling horizontally, right? So technically it can just keep bouncing up and down, right? But to show that it's difficult, which is why I had to show it like this. But vertically, how much distance does it cover? Suppose it keeps bouncing for thousands of times. Okay, Moksha's hand is up. I'll wait for some other answer. Sarah, I'll wait for your answer. Okay. Meanwhile, whoever has answered can put it on the chat. Okay, Amit has put an answer on the chat. Moksha can do the same if you done it.
So are we supposed to use S infinity over here because you said?
Yeah, that's what I won't explicitly say that, but yes, now that you're running it for the first time, that's what it means, right? Thousands of times its bounce means it's converging to a value.
Okay.
Or during its lifetime, let's say it keeps bouncing. Okay,
Okay,
Um,
I got the answer, but I don't think it's right.
okay. Before you call out your answer, I want to say both Amit and Moksh, both your offline answers seem wrong. I think, I mean, I could have done some mistake as well. I just was trying to mentally work it out. Yes, just check once, Moksh and Amit, since you called out your answers on the chat. Okay, Sarah, go ahead, please. What is your answer?
So I did A over 1 minus R. I took A as 10.
Yeah.
Or 1 minus 5 by 6.
Yeah.
So that's 600.
Okay. Okay. 60 or 600?
Sorry, 60.
60, right? Okay. So,
So the question was the vertical distance it traveled.
total vertical distance the ball traveled during its lifetime.
So would that be 60?
Okay. I'm going to ask you. It may be 60, it may not be 60. Tell me why it's 60. Just because A by 1 minus R is working out to be, I need a connection between the problem given and the formula that's been used.
So we said S infinity. So that means sum of the distances it traveled vertically. So
Correct.
that's why the sum.
Okay. All right. So Sarah, can you call out the vertical distance, the ball? Amit, your corrected answer seems right. That's right. Moksh, I'm still waiting for your corrected answer. Okay. Sarah, so can you tell me the first vertical distance it travels? Will it be up or down?
It's dropped from a height of 10, so it'll be down
And how much distance?
10 meters.
Okay. Now the next bounce, so the next vertical will be going up, right? And how much will it travel? 10 into 5 by 6.
Yeah.
Okay, I'll just 10 into 5 by 6. The next motion will be up or down, and by how much?
It'll be up. So
How will it be up? It's already up. It has to fall down, right? Before it goes up.
yeah, so it'll be the same distance.
Exactly. Right. So what you're seeing is not a geometric progression per se, right? You have
Yeah.
10, then you have 10 times 5 by 6. The same value is repeating now. And what is the next one after this?
That'll be 5 by 6 of the previous.
Exactly, which will be 5 by 6 whole square, and then 10 into 5 by 6 the whole square again.
Yeah.
So it's like a geometric progression, but it's not direct formula substitution, right? So I want to realize it's not just a 10 times 5 by 6, 10 times 5 by 6 whole square and all that, right? There are some repeating pairs. And the first one is alone single. That's also something to pay attention.
Yeah.
Now with this, can all of you work out and give me a corrected number again? Guys, your attempts are still inaccurate. You've given me 2 answers, both are wrong. And Moksh, your second answer is also wrong. Yeah, this question is very error prone. So don't worry too much, but I mean, you should worry. I'm just saying, right? It's error prone. A lot of scope for silly mistakes. Dave, you're following along, right? Completely so far?
Yes, sir.
Okay. Yeah, I'm going to ask Amit to explain the answer, but hold on for 1 minute, 30 seconds more, Amit. I'll see whether people have corrected answers. You can just call out, guys. You don't have to put on the chat. I mean, by now, enough time has been spent on the problem. Okay, can we discuss, Moksh? You still think your answer is right, 120?
Yeah, I do.
Okay, Amit, can you explain your answer?
All right. So the initial drop is 10 meters, and then after that, it follows the sum to infinity pattern. But as you demonstrated, you have to multiply it by 2 because there's the first, upward motion and then the downward motion. So then you have 10 to the 5 by 6 over 1 minus 5 by 6, which is 50. We multiply that by 2 to account for the bounce upward and downward and add the initial 10 meters that it's dropped. So in total, it's 110.
That's correct. Okay. Yeah, and I understood, but just so that everyone is on the same page, the mistake Moksh and probably some others also have done is this 10 is alone. It does not have a pair. So in some ways, I can write a new geometric progression as this 10 is unique. I'll collect these two and write it as one term, right? There is 2 of this 10 5 by 6. And then there is 2 of these 10 times 5 by 6 whole square. And then similarly, there'll be another pair, which 2 of 10 times 5 by 6 whole cube, because it's up, down, up, down, up, down, right? Only the first one alone is just down. Everything else is up, down, up, down, up, down. So I'll start counting my geometric progression from this point on, because I won't include this in the geometric progression because it's not following that pattern of common ratio, right? It's unique. So my starting point is 2 into 10 into 5 by 6. How much is that? How much is that? Simplify to, I think 315, 150, I guess.
50 over 3.
How much is it?
50 over 3. 2 into 10 is
Yeah, 50 over 3. Sorry, my computation. Okay, 50 over 3. And then the common ratio is 5 by 6. So the sum of infinite terms is a by 1 minus r, which is 50 by 3 upon 1 by 6, which is 100. And now to this 100, we have to add this extra 10 that was unique. So the total vertical distance is 110. Another way you could have done the same problem is, I could have, just by symmetry, I could have added a 10, right? I'd say, okay, fine. I'll put another fake 10, but I'll compensate later. So this 10, I'll keep it to the end. And then I'll start counting my geometric progression as 2 times 10, 2 times 10 times 5 by 6, and so on. But I'll subtract it at the end. Effectively the same thing, right? So if I do that, then in my new case, if I start counting as if the starting term is also a pair of 10s, then that's 2 times 10, right? Which is 20. Common ratio is 5 by 6. Same thing. So 20 upon 1 by 6, which is 120. But then I've included a minus 10 at the beginning, right? For compensating. Again, it leads to the same 110. Either 100 plus 10 or 120 minus 10. Both lead to the final answer of 110. Right? Is this clear, guys? Guys, you're completely with me. Sarah, did you understand? Okay. Okay, one more problem in geometric progression. Okay, let's pick 2 people here. Okay, fine. I'll say Thais and Moksh. Okay. So what's going to happen is, initially Thais has some, let's say $400 with her. Okay. And Moksh has nothing. Okay. And they play a game. So this is day 0. Day 0. On day 1, Thais will give half of what she has to Moksh. On day 2, Moksh will give half of what she gave in the previous day. So 100, right? And then day 3, she will give back half of what happened in the first day, right? So this is 200 transacted, here is 100 transacted, here 50 is transacted. This becomes 250 and this is 150. And they play this game for, let's say, 1 year, means infinity, right? Back to Sarah's question, people won't explicitly say infinity. They'll say they play this game for a year. Approximately how much money will they each end up having? Can you guys work it out? I say approximately because infinity is not 1 year. Infinity is infinity. But very, very practically speaking, 1 year is like infinity only, given this transaction is happening 365 times. Okay. All right. I have a few answers here. Yeah, Moksha, your answer is right. Dave, check on your answer. Amit, your answer is right. Sarah, your answer is wrong.
Sorry, sir. I have a question. I forgot.
Yes.
What the question?
Oh, the question
Sorry.
is, at the end of this game, after a year later, how much money will you have? How much money will Moksha have? Because every day your money in the bank is going up and down, up and down. Sarah, maybe you also misunderstood the question based on your answer, right? It seems like you misunderstood the question. Can you try again, please? Amit, turn on your video, please. Hope your internet is stable, right, today?
A little more, yeah.
Oh, okay, Amit, I just skimmed through your question and said you are right, but yes, you corrected and I didn't notice that subtle difference, but yes, you're right and you found your own mistake. That's good. Okay, let's discuss, guys. Okay, so let me put myself in. Okay, Moksh, why don't you explain your answer?
Okay, so my answer was that at the end of this game, Thais would have approximately 800 upon $3, and I would have approximately 400 upon 3.
Okay, yeah, please explain your answer.
Okay, so I found it easier to focus on Thais' balance rather than my personal balance.
Okay,
At the starting, let's imagine before the experiment started, she had $0. Okay.
Yeah.
Then she gained plus 400. Then she lost 200.
Yeah.
She gained 100. Then she lost 50. And we can easily see this is a summation of the infinite series, 400 minus 200, 100 minus 50. So the first term A is 400. The common difference is minus 1 upon 2. And then we can just plug it into the formula to get the answer is 800 upon 3.
Exactly. Very well explained.
And
as
then
well.
you can tell that in the whole system, there's $400. So I can just do 400 minus 800 upon 3 to get my balance.
Excellent. In fact, that is another point that I wanted to touch. You don't need to redo the same thing to calculate Moksha's answer. You can directly say the entire money has stayed in the system, meaning between Thais and Moksha, no other third party came, right? So the entire money should have been between them only. The answer could be 300 and 100. It could be 200 and 200, but it'll never be 350 and 200 because no extra money could have come into the system, nor could it be 150 and 100 because this money could not have evaporated from the system. One basic sanity check is both the answers should add up to 400. But that said, Moksh, always to be on the safer side, independently calculate it so that if at all you did a silly mistake in calculating this, that will come to light when you calculate Moksh's answer, right? And that could be a good sanity check. That way you have super confidence. Let's say, for example, in this calculating this, you made a small mistake and you calculated this 700 by 3, let's say. Then your other answer is also wrong because you're dependent on other. While it's true that it is 400 minus your answer or 400 minus Thai's answer. But because there's a mistake here, the mistake will carry forward to the other also. Okay. Did I lose people on this one? Sarah, did you understand the point I'm trying to make? Okay. So, okay. So first of all, as he explained, right, he's just looking at Thai's balance and then the total P&L, right? Profit and loss. Let's say she gained 400, she lost 200, gained 100, lost 50, and so on, right? And that's fairly easy to see. It's 800 by 3. And then let's independently do it for Moksh. So Moksh started with 0. The first day of his gain was 200. Then he got a loss of 100, gain of 50, and so on. So independently, I'll do Moksh separately. R is minus half again. So it's 200 upon 1 minus half, which is 3 by 2. So which is 400 by 3. And now it's comforting to see that 800 by 3 plus 400 by 3 is 1200 upon 3, which is the expected 400. So I can be super confident saying I didn't do a mistake here, I didn't do a mistake here, and the sanity check also passes. As opposed to having that fear that, let's say he calculated this wrong and 700 by 3, then he would have just done 400 minus this as 500 by 3 here, and both answers would have been wrong, right? So it's good to have the sanity check, but do independent calculation and then apply the sanity check. Only then it's a true sanity check. Okay, wonderful. All clear so far? They completely with me on this? Okay, cool. Let's do some
got it
problem.
now.
Okay, super. Let's do some problems from geometric progression. Okay, so actually this is okay, all right, let's do this. Can we do this? It's fairly formula substitution, but just so that you have practice. Common ratio is minus half. So when I first read it, I read it as half. The fraction and this is minus half. I hope people notice the negative sign. Did anyone not notice? Like me initially?
No, sir, we got it.
Okay. Okay, Sarah, you have something for me?
I've gotten A for now. I'm just doing N.
Okay, what is A? Please call out.
48.
48, okay. And N, Dev?
Yes, I'm just fine.
Okay, Moksha has an answer. Let's see. Amit, you have an answer as well? Yeah. Okay, call out your answer, Amit.
10 terms.
10 terms. Okay. Okay, so Amit has 10, Moksha has 9. At least one of them is wrong. Probably both are wrong. I'm just kidding. I don't know. I haven't worked it out. I'll do it with you guys. But both of you check once, no? since there is inconsistency.
I'm
should
the
not-
wrong one. It's 9.
It's 9. Okay, you
Forgot
agree?
it's not n-1.
Okay. Yeah,
for
it should
some.
not take so long, guys. So let's do it. Okay. So A times, I'll use the 1 minus r power n. 1 minus r power n. It's here n here, not n minus 1. Remember, guys, in case you did that, right? And then 1 minus r. And that's it, right? That's given to be 32 1 by 16. All right. 32 1 by 16 is so irritating, right? How much is this? 513, I guess, divided by 16. Okay. So 1 minus half is 3 by 2. 3 by 2, when it goes up, 48 times 3 by 2 becomes 72, sorry.
So it's 48 divided by 3 by 2, not times.
Oh, okay. You're right. My mistake. 48 divided by 3 by 2 becomes how much then? 32, right? So it's 32. So it's 32 times 1 minus half power n equal to 5 1. In fact, I'll leave it like this: 32 1 by 16, right? And then this 32, when I take it outside the bracket, it becomes easy, right? So 32 minus 32 into minus 1 by 2 power n equal to 32 minus 1 by 16. So this makes it easy. The 32 I can knock off this 32 and this 32. And then I put the plus sign here and plus sign here. Am I right? So sorry, it was indeed plus. Sorry, it was indeed plus. So this stays minus. Sorry, guys, it's very messy what I've written, but you guys have it, right? So it's 32 plus 1 by 16. Okay, so obviously n must be a negative number, n must be an odd number.
So you
Yes.
can do another step. Instead of multiplying the brackets by 32, you can just divide both sides by 32.
Yes.
And you get 1 plus 1 upon 2 to the 9.
Yes. Yeah, we can do that as well. So having done this, I'll just take the 32 to this side. I'll just say 1 by 16 times 32 here. And this minus half power n, which is negative here, right? Negative. And then this itself shows that n has to be an odd number. And very easy, right? 2 power 4 and 2 power 5. So n is 2 power. So this is 2 power 4 and this is 2 power 5. So n has to be 9. Dave, same answer, 9.
So I didn't get it.
But now did you? When
Yeah,
we discussed?
now I did.
Okay. Yeah. And you agree it's just calculation, right? Nothing, it's just
Yeah.
plain substitution. Okay. Moksh, you had a question or your hand is up from before? Okay. Cool. Okay. Let's switch gears to arithmetic progression from yesterday. Let's see whether you guys remember this. So show that first we'll discuss A part. Okay. And then hold off before we do the B part. So for any sequence, n is Sn minus Sn minus 1. What do I mean by that? Okay, one sec. I just want to hide this for a second so that people don't get distracted, right? So suppose I have a sequence which is not even arithmetic progression. Let's say 1, 4, 9, 16, 25. It's just a sequence of perfect squares. This is also a sequence. It's not that every sequence has to be arithmetic or geometric, or for that matter, it has to follow in a particular pattern. The pattern might be very, very weird. But it's still true that to find out the fifth term, so U5 is 25 in this case. But we all know U5 is S5 minus S4. Because if I sum all the way till 5 terms, and if I subtract the sum till 4 terms, by definition, I'll get the fifth term. So irrespective of what sequence it is, this property is always true that nth term in any sequence is the difference between the sum till n terms and the sum till n minus 1 terms. Now, why would people do this? I mean, if at all anything, finding the term is easy. Finding the sum requires more effort is what the general opinion is. But that's not true. Sometimes it might turn out to be that finding the sum of n terms is easy, but finding a specific term is harder, which is why you want to have this option also handy. As in, if I know the sum till n terms, which means I have a formula in terms of n, and in the same formula, I substitute n minus 1 instead of n, then I get Sn minus 1. And the difference between these two gives me the nth term by definition for any sequence, right? Thai, you with me? Thai, you with me? For any sequence, this is true. Yeah. Now, in particular, in this problem, he's saying, show that for an arithmetic sequence, this property holds good. Meaning you have a formula for un, also have a formula for Sn, and plug both of them and see, verify rather, right? I would say verify. Verify by looking at un calculation and looking at Sn calculation and seeing both match. Can you do that, please? If the question is clear to you, all of you know. Sarah, is the question clear to you now? Yeah.
So you already showed part 8. We need to do it ourselves.
Did I do part A? No, I didn't do. I didn't do. When? I just said it's true for any sequence, but verify that it's true for arithmetic
Fine.
progression
Okay,
using the
cool.
formula for un and using the
Cool.
formula for Sn. That's what I mean. Okay. So calculate LHS, calculate RHS, and show that they are indeed same. Dave, you're okay, right? You seem a bit lost or okay, okay, good.
Thinking.
Okay, cool. No, you're so focused. So maybe I thought you're a little confused. Amit, is it verified for you?
Yeah.
Okay. Let's see. Dave, have you verified?
So I'm trying to input like the sum of an arithmetic sequence and the nth term and trying to equate them to see if it is.
Yeah. So those who have verified can do the B part now. Moksha, verified?
Yeah, so I'm working on B.
Okay, cool. Okay, I'll work out part A in case anyone is stuck. You can just refer. I'm not going to speak. I'll just work it out.
So
You can
could you
just-
explain what question B means? I can't even understand what it's trying to say. Like,
Okay,
So
Sure.
verify
you
question
mentioned
A.
the leading variable, the running variable, but this expression in the sigma notation doesn't even have a running variable.
it has no UI, U suffix
Is-
I.
Isn't that like a suffix? It's not being operated on.
That's true. It's a suffix, but yes, it's like U1 plus U2. Okay, before I answer that, Moksh, Dave, you said something. What was that? And part A, you got the answer.
Yes, I got part.
Excellent. Sarah, you want me to recap part A or you're all good at that as well?
No, I got it.
You got it, right? Thais, you're also good, right? So all of us verified. Just substitute A plus N minus 1 times D here, and then substitute the formula that we saw here, N times, or whatever. You can put the by 2 later, or A plus N minus 1 times D. Sorry, guys, I'm just scribbling here. And for Sn minus 1, wherever N is, you replace it with N minus 1. And then the difference between those two big expressions should turn out to be this. Sarah, you with Thais, you got the same answer for part A? You're able to verify, right? Okay, cool. All right. So I'm assuming part A is done for everyone, right? Now part B, back to what Moksh is asking. Yes. So what does this mean? This is as I goes from 1 to n. So it means u1 plus u2 plus u3, so on till un. Yes, he has not given an expression for what ui itself is in terms of I, but he's saying, given that u1 plus u2, so on till un is this expression, find a general term un. The question is clear, right, Moksh? Okay. And the hint is part A. Part B is just an application of part A. So this is Sn, right? So knowing Sn, I can find un. That's it. If you didn't follow still, I'll give you a minute to think about it and we'll discuss, of course.
I think I got it, sir.
Okay. Hold on for a minute and then I'll ask you to call your answer, but I don't want to bias everyone with your answer now. If someone else has an expression for un, please call out. Oh, I see some chat.
Hang on, sir. I think that's wrong. Give me.
Okay, all right. Okay. I'm going to put Amit's answer here. I'm not saying it's right or wrong, but if someone else gets the same thing, that'll be assuring. Okay, I'm not saying it's right. I'll do it in two different ways. One using the application of part A and one other way as well. Moksh, are you getting the same answer as Amit? 3n minus 2 or getting something else?
Hang on, let me just check my answer once last time to see if it matches Amit's answer. I think Amit's answer is correct. So I'm wrong.
Oh no, you already called out your answer is wrong. I'm just saying in your reattempt, did you get the same answer? That's what I meant.
Yeah, Amit's answer is correct.
Okay. As in, Moksha has so much confidence that now the answer matches. His answer is right. Okay, at least the answers are matching is what he means. Shall we discuss, guys? Thais, shall we discuss? Okay, Sarah, you're almost
Yes,
done or? Okay, all right. So Sn is what? Sn is given to be n by 2 times 3n minus 1. So I'll write it as it is. And then Sn minus 1 is what? Wherever n occurs, I'll put n minus 1 instead. So n minus 1 by 2 times 3 times n minus 1 minus 1. I'll just follow the same pattern, except that every n gets replaced with n minus 1. That's it. And now I'll do the difference between these two, right? The difference is my un, right? The difference is my un. So what is it? So I'll keep the 1 by 2 outside since it's always outside. So n times 3n minus 1. So it's 3n square minus n minus 3 times n minus 1 whole square, right? So it's 3 times n minus 1 whole square. So it's 3n square minus 6n plus 3, right? That's 3 times n minus 1 whole square. And then minus of n minus 1. So minus minus becomes plus. Right? I mean, just doing simplification, nothing big. right? So 3n square cancels with 3n square, minus n cancels with this plus n. So what I have ultimately is 6n minus 3 minus 1 whole divided by 2, which is 3n minus 2 indeed. Right? Well done, Amit. Does it make sense, guys? Sarah, are you with me? They same answer now. Does it make sense? Okay, very
Yeah.
almost
actually-
close to finishing. Dave?
No, so I actually put the difference, but then I couldn't solve it fast enough.
Okay. Okay, that's fine. Slowly it'll come. All right, just keep practicing. Okay, now can anyone think of another way of arriving at the same 3n minus 2? The problem is up here.
So I know of it.
Okay, go ahead, Moksh. Tell me, please.
It's summing, like the summation of ui, which is the ith term,
Yeah.
is basically just the summation of the whole series Sn, right?
Yeah.
So Sn is n upon 2 times the average of the nth term and the first term, right?
Yeah, yeah.
So we can just cancel the n upon 2 from the Sn formula and this sigma, the expression in the sigma. So we can tell 3n minus 1 is just the initial number, a
Plus the last number.
Yeah.
Exactly.
So that's just a plus n minus 1 times d.
A plus n minus 1 times d. A
Yeah,
occurs
sorry.
twice. Yeah,
Sorry.
that's what it is.
2a plus n minus 1 times d.
Perfect, perfect. And then see the by pattern recognition, you see this.
Yeah, yeah.
Yes.
I
Just
think that's why I got a mistake. I didn't do 2a, I got a. That's why my answer was different from Amit's.
I see. Got it. Okay. So just to explain.
Alternatively,
Yes, go ahead, Amit.
rather than doing that, you can just keep it as a plus un and then find u1 by doing the summation of the first one term, which is just u1. And once you have that, you can solve 3n minus 1 equals to 1 plus un equals to 3n minus 2. It's much
Excellent.
simpler.
Excellent. Yes, I'll go through both methods. First, whatever Moksh explained, and then whatever Amit said, I'll touch on that as well. So we have three methods at the end of this. One was a pure application of 14a. We just did 14b from it. Now, what Moksh said, first I'll cover that. So basically, I mean, in case people didn't follow along. So, okay, so we know that Sn is, the formula for Sn is n by 2 times the sum of the first and the last term, right? So a plus n minus 1 times d. Okay, now that is given to be, in this problem, it's given to be n by 2 times 3n minus 1. N by 2 times 3n minus 1. Now, like before, we can just do a pattern match, right? N by 2 gets cancelled, right? N by 2 and this n by 2 are same. So effectively, I'm saying 2a plus n minus 1 times d is my 3n minus 1. Okay, so I'll collect the terms which are dependent on n together. So on the left hand side, it's n times d. And then the terms which are independent of n are the rest, 2a minus d, right? So 2a minus d plus nd. This should match with minus 1 plus 3n. Right? The right hand side, I'm writing it as minus 1 plus 3n. So from this pattern recognition, I can see that my common difference d should match 3. The common difference d is 3. And then once I put d, right, I can find a, because 2a minus d. Okay, so 2a minus d should be my minus 1, right? So which means 2a is minus 1 plus 3, which is 2, which means a is 1. So I know my a, I know my d, therefore my un is a plus n minus 1 times d. So 1 plus n minus 1 times 3, which works out to be 1 plus 3n minus 3, which is the same 3n minus 2. Rahul, you're with me completely on this one? Not Rahul, Dev, I'm sorry. Rahul is Dev's dad. All right, I remember.
Yeah.
I always get confused. Okay, so 3n minus 2, right? Moksh, you've written 3n minus 1 on the chat, or was that from before? Okay, I think that was several
That was
minutes
from
ago.
before I
Okay,
realized
okay.
that was wrong.
Okay, all right. So this is 3n minus 2. Now, what Amit is doing
Sir,
on...
sorry.
Yes, Thais, go ahead, please.
How did you get from the second line to the third line? Actually,
Second line from here to here.
no.
Okay, can you annotate? You should have. Can you show me where? You can put a marker somewhere. On the page, are you able to, or? Oh, okay. Okay.
Yeah.
No, yes,
Okay.
yes. So in this problem, it's given that n by 2 times 3n minus 1 is the sum till n terms in this problem, right? And then I'm saying n by 2 can get cancelled. This n by 2 and this n by 2 can get cancelled. Are you with me, Thais? Sure, right? Okay. So that's all I did. I cancelled off the n by 2. That's all. I mean, all right. I should not be cancelling here because Sn still needs the n by 2. But when I'm equating this and this, I can cancel off the n by 2. Right, guys? Okay. Now, what Amit added another extra flavor on top of that. He said the following. Again, let's start from the beginning, right? So we all agree that Sn in the problem is given to be n by 2 times 3n minus n. But we also know that in general, the formula is n by 2 times the first term plus the last term, a plus n minus 1 times d. Okay, so we know this. Now, what he's saying, what Amit is saying is, let's do S1 based on the formula that's given. What is S1? S1 is the sum till the first term, which is the first term itself. So S1 is unique in the sense the sum till one term is nothing but the first term itself, right? From sum till 2 terms, we understand first term plus second term. Sum till 3 terms, we understand. But sum till 1 term is literally the first term. So he's saying S1 is your U1 or A, whatever you want to call it, T1, whatever. Just by putting n equal to 1 in the formula for Sn, I get my first term, right? And what is that? 1 by 2 times 3 minus 1, which is 1, which means I got my A right immediately, right? And then now it becomes so much easier, right? So n by 2 times 1 plus 1, which is 2, plus n minus 1 times d, right? I found my A already, so my D is very, very easy now, right? So 3n minus 1, again, the same thing, right? So 3n minus 1 should match my 2 plus n minus 1 times d. So from this pattern recognition, you can see that the term that depends on n is this nd, and the other term is this 2 minus d. So that part is similar, right? So 3n and minus 1. So my d should indeed be 3, and it's consistent. If I put d is 3, 2 minus 3 is also minus 1 as expected, right? So it's slightly shorter that way. Well done. Are all methods clear? Sarah, you with me completely on this? Okay, cool. All right. Now let's go on to an application of geometric progression. Another application of geometric progression is your compound interest. So in your bank, there's simple interest and compound interest. So in simple interest, okay, this is a general expression, right? The amount that you have in your bank is your initial principal plus your interest earned. So for simple interest, your I is calculated as your P into R into T, right? Sometimes people write PRT by 100. I don't like to do that because R is already a percentage. If R is 8%, it is 8%. The 8 by 100 is understood. You don't need a further divide by 100 and confusing things. So I is just P times R times T, right? And then you calculate your amount as P plus PRT. So it becomes P times 1 plus RT. But in terms of compound interest, the amount is what is derivable and interest is in terms of the amount. So amount is P times 1 plus R whole power T. Okay, and you to calculate the interest, you do the amount minus the initial principal, right? So the main difference is in the simple interest, the interest leads us to calculate the amount. In compound interest, the amount leads us to calculating the interest, right? Amount is more basic. That calculation is more basic, and then your interest is derived based on the amount. But this is a general formula, irrespective of whether it's compound or simple. Amount is principal plus interest. All of us know this. I'm just quickly recapping it, right? So what is the connection with arithmetic, with geometric progression? The this amount that we have in the bank is a geometric progression. Why? Because at the end of, if I put t, and if I put amount as a function of t, right? I am writing as a of t, like a function of t, or I'll just say at maybe, right? I'll just say a suffix t. Both mean the same. Whenever you see this, something like this, at, if you have not studied functions and you're new to functions, this you can almost assume it's a of t, like y equal to f of x, that type of thing, right? All of you have some basic introduction to functions, right? Would have seen some functions. Okay. So if I put t equal to 0, then the amount I have in bank is p times 1 plus r power 0, which is just p, because I'm just investing. After 1 year, let's say it's all compounding yearly. So it's p times 1 plus r. And then after 2 years, it is p times 1 plus r whole square. So this is a geometric sequence, except that the common ratio is 1 plus r. And it's a little confusing because the common ratio, generally we are used to writing it as small r. So just for the purpose of geometric progression, I'll just say the common ratio capital R is your 1 plus small r, which is r is your percent. For example, it's 1 plus 8%. So the common ratio is 1.08. So every year, your money in the bank grows by 1.08, 1.08, 1.08 times what the previous balance was. Okay, so that's fairly simple, right? A simple geometric progression could be as simple as you put $1,000 in your bank every. Okay, all right. So every year it's so yearly compounding. Let's say yearly compounding. Yeah, actually, this is an important point, right? So yearly compounding of 8%, 8% per year. All right, 8% per year. Okay, then what the question could be, how much is your balance after, let's say, 5 years? Okay, so all of us we all know this. So 1,000 times 1 plus 0.08 whole power 5. Okay, right? Now, what is interesting is not always the compounding is yearly. You could have, for example, a quarterly compounding. Okay, I'm just ignore my spelling. I'm just going to scribble here. Quarterly compounding. So when you say quarterly compounding, but what is the rate of interest? Let's say it's 8%. So quarterly compounding at 8% per year. So this is confusing, right? What this means is the interest equivalently for the year is 8%, but the compounding frequency is every quarter, which means literally you're getting a 2% interest. 8 by 4 is 2%, right? 2% interest every quarter. So let me just make more space here. I need more pages now. Where did I lose this? Okay. All right, I'll take another page. This is. Okay, so it's 8% per year, 8% per year, compounded quarterly, compounded quarterly. So you have to change your formula slightly. In this case, it becomes P times 1 plus R by N power T times N, where N is the number of times it gets compounded in a year. So N is the number of compounding periods in a year, right? Right, I say year because this rate of interest is defined per year. So in case of compounded quarterly, therefore N equal to 4 because it gets compounded 4 times in a year, right? There are 4 quarters in one full year, therefore 4 compounding periods. So in our case, it will become $1,000 times 1 plus 0.08 by 4 times 5 years, but each of them has 4 compounding periods. So it becomes 1,000 times 1.02 power 20 versus initially we had 1,000 times 1.08 power 5. Now you see that this base has gone down, but the power has increased. And The power is where the real power is, hence very aptly named power, right? So the second expression will be higher in value, right? So for the same 8%, seemingly same situation, the more compounding frequency it is, the more value it is for you. If you have invested, then you would always prefer the latter, right? Because it's going to give you more money at the end. And you can quickly plug it in your calculator and just check. Although both answers will be fairly close, but if you're investing not $1,000, but let's say you're investing, let's say you're a billionaire like Moksh, and you're investing $100 billion, then it makes that huge difference, right? Okay, now I can take it to the limit now. What if compounding happens every day? So if suppose it's daily compounding, then n is 365, right? So again, I'll write the expression here. So it's 1,000 times 1 plus 0.08 by 365 times 5 times 365, 5 years and 365 periods in each compounding period, right? Right? And then you can take it even further. Let's say your interest is getting compounded every nanosecond. That's literally called continuous compounding. So continuous compounding is literally it's getting compounded every nanosecond, which means n is approaching infinity, right? In such a case, so again, what is the expression? Suppose it's 1,000 times 1 plus 0.08 power n times 5n, right? So because n is very, very small, sorry, n is very, very large. So this will seem like approximately, I'm just saying 1.0000000, some like lot of zeros, and then maybe 2, 3, something like this. But the number at the top will be a very big number, like 5 zillion or something, right? And this will be the one which will give you the maximum. Obviously, this will also be a normal finite value, right? It won't be a very big number because the base is very, very close to 1, but slightly more than 1. But the power is a huge number, so there's some compensating factor. But this is the one that will go that'll give you the maximum interest or maximum amount, and hence the maximum interest. Now, what will that maximum interest be? So suppose we have to generalize this and answer that question. So let's understand one. I mean, we'll cover this more in calculus because this is nearing your domain of calculus. But since we are in discussing geometric progression, I cannot skip over this portion. So fundamentally, in calculus, there is one result. Just take it for granted for now, right? There is a result which says 1 plus h power 1 by h, right? If h is a very, very small number, small as in it's very close to 0. The way you write that in calculus is limit, right? LIM stands for limit. H tends to 0, as in h approaches 0. So example, I just say an example. Can you pull out your calculator and just do h equal to 0.01. So 1 plus 0.01 power reciprocal of 0.01 is 100. If you do this, approximately you should get 2.71. Can you guys confirm you're getting that? Right? So, and this is your E, right? Approximately, just like pi, it's a numerical constant, mathematical constant. This is another famous constant in maths called E. So the expression for E is limit h tends to 0, 1 plus h power 1 by h. If you do even 1.1 power 10, we don't even need to go that far. Even this will be fairly close. Maybe this will be 2.69. I don't know. Can someone work out and tell me what is 1.1 power 10? If you have a calculator handy, Dave, can you call out if you have it?
It's 2.59.
2.59, is it? Okay, I thought it'll be much closer to 2.71. But to 1.01 power 100 is 2.71, is it?
I think it's 2.
No, it cannot be 2. It has to be much. It has to be much bigger than 2. 1.1 power 10. Guys, do you have a calculator as well with you?
For 1.1/10, I found 2.6.
So for h equals 0.01, it's 2.704.
2.704. Okay, so 2.704. Okay, for this, and then for this one, it's 2.59 or 2.6. Okay, so and if you do 1.001 power 1000, I'm sure it'll be 2.71. right? As you keep decreasing h, maybe I should have written in decreasing order. I put the 1.1. I should put the 1.1 power 10 at the top, right? So that you can see it's approaching. So it's 1.1 power 10, as Thais called out, was around 2.6 or 2.59, whatever. Now 2.704, and then it's approaching 2.71 when you do 1 point, right? But essentially we all get the idea. 1 plus h power 1 by h is e, right? Now we can apply that for our compounding problem. So back to this problem, how do we apply that here? For our 5-year compounding at 8% every nanosecond. So suppose we have to evaluate this expression. I can do a small tinkering with this. So 1 plus 0.08 power n, okay, power 5n. Now what I'll do is I'll replace the 5n. I'll still simulate the 5n. I'll replace the 5n by writing it as a reciprocal of 0.08 power n, right? N by 0.08 into 0.08 power 5. Sorry, 0.08 into 5, sorry, into 5. Right? So all I've done is the 5n is nothing but I still have the n times 5. Right? I'll write it as n by 0.08 and then times 0.08 into 5. So we all know that from basic exponentiation, we have a power m whole power p. It is a power mp, right? I don't want to put another n and confuse, but essentially a power m whole power p is a power mp, right? So which is why I can write this as this 5n instead of this 5n. I'll write it as n by 0.08. And I'll write this whole thing power 0.08 into 5. Are you guys with me? Do you agree with me, guys? Sarah, do you agree with me? You have no choice. You have to. Okay. No, seriously. Right? Makes sense, right? Okay. Now, Sarah, this expression in the big bracket is my E. Do you see that? Because my N is a zillion now, because I'm compounding every microsecond. So this is similar to this 1 plus h power 1 by h. My h is my 0.08 by n. My 1 by h is n by 0.08. So what I have in this big bracket is now E. So it is 1000 times e power this 0.08 into 5. Or more generally, it's p times e power RT. Right? So if you compound infinitely many times, it's also called continuous compounding. Your total amount at the end of the tenure is p times e power RT. And this will be the highest. You cannot beat this sort of compounding. That's the best any bank can offer you, right? If Bank A offers 8% compounded annually, Bank B offers 8% compounded quarterly, Bank C offers 8% compounded daily, and Bank D offers compounded nanosecondly. Then the last is the what you should choose, which will be your interest, your amount in the bank will be p times e power RT. E is just a number, 2.71. Okay, so that's that. We'll of course cover it more in calculus. Okay, Amit, I'm just seeing your chat for 1.1 power 10. Yeah, it's around 2.59. Yeah, sorry guys, I'm not always keeping an eye on the chat, but you can just call out, right, in case I don't respond to it immediately. Okay, now one other application of the geometric progression is in calculating the mortgage rate. So typically what happens in a mortgage, so I'll just draw a line, right? Okay, so this is your time axis, right? And then you borrow a huge sum of money from your bank, right? So let's say the bank has paid you, right? Some big amount, and then you go and return to the bank a small amount every year. Okay. And so on. Okay. So, okay. So the bank has lent you, let's say, $1 million, right? $1 million of loan. Okay. And now this is time 0, right? This is time 0, this is time 1, time 2, time 3, time 4, and so on, right? So let's assume years for now. In reality, it's months, but just so that we have the concept, we'll treat in terms of years, and we can always normalize it for months, no problem. So the bank has given you money, right? So let's say this is, I don't know how to mark it, but let's say this is the bank and this is you, right? So bank has given you money, which is downward, and then you are paying the bank every month, every year, sorry, every year, okay? And then the understanding is after, let's say 30 years, right? It's not 30, but I'm just saying 30 here, right? Okay. So after 30 years, you'll exactly repay the amount that's due, right? So the question is, what should my equal yearly payment be? So this is called equal yearly payment, right? In reality, it's equal monthly payment, which is why you would have heard the term EMI, right? You have to pay your EMI bill, equal monthly installment. Here in this fake example, I'm doing it yearly, equal yearly installment. So how much should you pay every year to tally out this 1 million, right? After 30 years. Obviously, it will be more than 1 million by 30, right? Because if you're paying exactly 1 million by 30, okay, let me make it 20 years so that it's a round number. I'll just say 20 years, right? If I just do 1 million by 20,000 by 20 is how much? 50, right? It's 5,000. If I pay only $5,000 every year, the bank will say no, boss, because that's zero interest, right? You're taking your own sweet time, 20 years, you're effectively paying the same 5,000 into 20 is 1 million. Why would I want to lend it to you? More realistically, you would end up paying maybe $7,362, right? That's the number we are going to calculate. I just randomly made up some number. How do we calculate what's a fair deal? If the bank says pay me $10,000 every month, then you'll say no, go away, in a polite way, but more harshly in a different way. But right, 736, how do we calculate this equal yearly installment is the question. Now here it's compound interest at play here, right? How is compound interest at play here? So let's generalize in terms of okay, so P is my principal, so P is my $1 million, okay, or 1 million. Okay, now let's say the rate of interest is 6% per annum. Okay, and just to make things easy, I'll just say compounded yearly only. There's no multiple compounding and all that. Let's make it easy, right? Compounded yearly, right? And what else I was going to say? The time that's given to you is 20 years. Okay, now you'll have to calculate. What should you calculate? You should calculate what the equal installment is. Let's call that X. What should my X be every year? That will make this a fair deal. So that's the question, right? So now let's work it out in terms of general terms, and then we'll substitute and find an answer very easily, right? So my initial principal, so this is let's put a table here. So this is T, right? And this is the amount you owe the bank. Okay, so at T equal to 0, the moment you step out of the branch, right, the entire amount principal is what you owe. For example, you can just go back in an hour and say, I don't want this loan, and you can just pay it. In reality, it does not work that way. There are some transaction costs and there's some other like bookkeeping work. But in an ideal world, you can say I can borrow and say after a second later, I say, no, I don't want it. I'll return the full amount. So at T equal to 0, I owe the bank this entire amount P. At T equal to 1, I owe the interest that's accrued is P times R, correct? Because P times R times 1, because it's literally, or no, I'll just say in compound interest, right? That's easier, right? It's compound interest. So therefore, the amount is P times 1 plus R, right? So just before I make the payment, so I'll just say 1 minus a fraction of a second. I'll just say 1 minus. 1 minus means just before I make the payment. But right when the clock strikes 1 year, I go and pay this X amount to the bank. So the amount I owe is only P times 1 plus R minus X, right? So just a millisecond before I make the payment, it's P times 1 plus R. Now I made the payment. So it's P times 1 plus R minus X. Now I forget going to the bank for the entire year, not forget. So 1 more year elapses. Just right after the 2 years, the amount that I owe is P times 1 plus R minus X. This entire amount, I mean, I say the amount very loosely here, this entire quantity has to be multiplied by 1 plus R. That's how much I owe the bank. But then a millisecond later, I come and pay the bank. Therefore, my balance is P times 1 plus R minus X times 1 plus R minus X. Right? Are you guys with me? Dave, are you with me? Okay.
Yeah.
Okay. Just so that it's not confusing, I'm going to remove this intermediate step. It was just for explaining. So I'll remove this intermediate step. So for all practical purposes, I'll count my balance just right after the payment is made. Right after the payment is made. So 1 plus means just a millisecond after 1 year has elapsed, I've made my payment, and therefore my balance is this. Now, if this continues for 20 years, just right after 20 years, I'll have a big expression, and I would have just made my last payment, right? And this amount finally should evaluate to exactly 0. Only then it means my loan is completely paid off, right? Because at the end of the 20th year, the amount I owe the bank should evaluate to 0. Using that, we'll be able to calculate what our X is. Are you guys with me? Sarah, are you with me? Okay. Right. Now, let's do one more expression, then you'll see it, right? At the end of 3 years, it'll be the same thing, right? So, okay, in fact, using 2 years itself, we can just see a pattern. So I'll just say at the end of 2 years, for example, at the end of 2 years, if I look at this expression, what is this? It's P times 1 plus R times 1 plus R. So 1 plus R got power 2, and then minus X into 1 plus R plus X into just 1. Right? So this X times 1 plus R and this X times 1. Right? So we can see a pattern here. After n years, so after n years, right after n years and after I have made the payment, my balance after n years, right, would be P times, just by looking at this pattern, 1 plus R power n minus, within brackets, X into 1 plus R power n minus 1 plus X into 1 plus R power n minus 2 plus all the way till X into 1. Right? Are you guys with me? Or rather, I'll just say X into, just so that I can follow the same pattern. I'll say X into, rather than saying X into 1, I'll just say 1 plus R power 0. Even though we all know it's 1, 1 plus R power 0 is 1. So my 1 plus R power ranges from 0 to n minus 1. So there are n terms here, right? And it's a geometric progression. We can see that it's a geometric progression, right? We're able to see it's a geometric progression, right? 0 to n minus 1 is n terms. So, right? Now we can apply the geometry. Are you guys all following along? If anyone has a doubt, you can just stop me. Okay. All right. Now here's where I'm going to apply the geometric progression. I'll just focus on this geometric progression. I'll just find the sum. So this sum, right? If I look at this sum, I can look at it from counting this way. That way it's clear. I'll just keep the first term as X times 1 plus R. In other words, my A is just X into 1 plus R power 0, which is just X, right? My common ratio, I'll use capital R because not to confuse with the 1 plus R. The common ratio is 1 plus R, right? And the number of terms is just n itself. Literally, the number of terms is n, because you're starting with 1 plus R power 0, you're going to 1 plus R power n minus 1. So the sum of this Sn would be A into capital R power n minus 1 upon capital R minus 1. Capital R is 1 plus R. Using the formula for the geometric progression, right? The only difference is this portion is your capital R, right? 1 plus R is my R, right? So what does this simplify to? X into 1 plus R power n minus 1 upon just R. Okay, so now I can just plug that in here, and I'll say at the end of 20 years or whatever, At the end of 20 years, this balance is 0, which means 0 equal to P into, okay. I'm just saying this N is a general N, but in particular, N equal to the end, right? End as in 20 years in our numerical example. So P into 1 plus R power N minus this expression that we just found, right? The sum that we just found, X into 1 plus R power N minus 1 upon R is 0, right? I mean, just so that is clear, this is a general expression. So in the intermediate state, intermediate values for N, it won't be 0. But when N reaches the final endpoint, maybe I should have used a different letter, right? So maybe I should call this K, right? For a general after K years, all right, it's so much, right? Here also I should have maybe kept after K years, right? It's so much, 1 plus R power K, 1 plus R power K minus 1. So this is after end of K years. But in particular, when K reaches N, and N is my duration of my loan, 20 years, then this balance must work out to be 0. And hence I can find my X because everything else is known. P is known, small r is known, N is also known. Therefore, I can find just X. In fact, X comes out to be, if I just move everything to this side, so P into 1 plus R whole power N times R upon 1 plus R whole power N minus 1. This is what my X comes out to be, right? Am I right, or am I doing some mistake, guys? Just please, can you check? I'm doing some mistake. No, right? Okay. Now, can you guys plug in your answer in this expression? Plug in P is 1 million, plug in R is 6%, and plug in N equal to 20, and see what value for X you guys get. Can you do that, please? It should be slightly more than $5,000. Not slightly, maybe 7,000. I don't know. Depends. I don't
So
have.
what should R be?
R is 6%.
6%.
And then we'll stop at this point, right after someone tells me what the answer is. Someone whoever works it out first, call out the answer, please. Just so that we have
87,184.5.
That seems too big, no? 87,000. Oh, okay. 80. Oh, yeah. What was my estimate? 1 million. 1 million is how much? Thousands upon 20 years, right? So
Yeah.
that was how much?
50,000.
50,000. No wonder. Yeah. This seems reasonable there. It should be somewhere between 50,000 and 100,000, which is why in my initial example, I said 5,000. That was a mistake, right? Which is why I was wondering, why is it so off? 50,000 is what I should have said. But 50,000 is like as if you're not paying any interest to the bank at all. So it has to be more than 50,000, but less than double of that. And 87,000 is roughly in that range. 87,000. What is that again? 87,000.
184.5.
184.5. Can all of you guys check later whether you get something like this? Hopefully, it's just a numerical calculation, right? Roughly, very rough sense check would be, like I said, it should be, if we literally assume the 0 interest, then it's the entire 1 million divided by 20 years, right? And that works out to be 50K. So somewhere between 50K and 100K is what you should expect, because 50K corresponds to 0 interest. 100K seems too high. Somewhere in between the two is what your typical interest rate. Of course, if the interest rate goes up from 6% to, let's say, 10%, obviously it can be even more, like maybe much more than 100K. But in realistic interest rate scenarios, you should expect something like this. Okay, is this application of geometric progression clear, guys? All of you. Okay, cool. The expectation with homeworks is, so since we are meeting both Saturday and Sunday, the homework I assign on Saturday, not all of you might have enough time to finish it by Sunday. I'll go a little easy on that. Again, I'm not going to check any homework. You're doing it for yourself. But definitely the following Saturday, whenever we meet, I expect both the Saturday and the Sunday homeworks to be done. And we'll touch on some of the difficult questions. We won't discuss all the questions, but 2, 3, maybe the first 15 minutes or so of the next Saturday class, I'll discuss the past homeworks, right? And then we move on to the next chapter. That's the progression that we'll have. Okay, so doing it for yourself. You don't have to send me the answers. Do it and check your answers at the back, and then really try hard if it doesn't match. And after 2-3 attempts, if it still does not match, then obviously, yeah, you can bring it for class discussion. But I don't want you to just try once and just say, give up. Okay, no, it does not match. Move on to the next one. Don't do that, please. Okay. All right. I'll see you next Saturday, same time, 2:30. Okay, bye.
Thank you, sir.
Thank you.
Thank you, sir.